Hi and hello to all amazing students, amazing people, and all lovers of chemistry out there. I'm super excited to be here with you on this third episode on acids, salts, and bases. And today we want to be looking at the concept of indicators and their uses. Alright, so without wasting time, let's go into what we have for today's video. First, let's start by defining what an indicator is. Alright, so an indicator, the word indicator was actually gotten from the word indicate. Alright, so when the word indicator is mentioned, it connotes that we are indicating something, and to indicate means to identify, or to show. Right, so when the word indicator is mentioned in chemistry, we are talking about a substance that is used to identify another substance, which brings us to the definition that we want to talk about very briefly. An indicator is a substance that changes color when it is added to an acid or a base. What an indicator does is that it helps us to identify whether a substance is acidic, whether it is basic, or it is neutral. Now, what an indicator does is that when it is added to a substance, it shows a color change. Now, that color change will now be used to identify if the substance is an acid or it's a base. Now, think of an indicator to be like a color detective. It gives you clues without needing to taste or touch dangerous chemicals while you are in the laboratory. All right, now that brings us to the first indicator that we want to talk about in this video, the litmus paper. Now, this is one of the most popular and common indicators in the chemical laboratory. Now, here is what litmus papers look like. Okay, and they come in two varieties. The first one we have is the blue litmus paper, and then the second one we have is the red litmus paper. Now, how a litmus paper works is that you insert it into a substance, in most cases liquid substance, that you want to test whether it's an acid or it's a base. Now, when you put a blue litmus paper, for instance, in an acid, it will turn red. So when you see a color change from blue all the way to red, it tells you that that substance is an acid. But if you put a blue litmus paper in a base, it doesn't change any color, it will stay blue. And when you put it in a neutral substance like maybe pure water, which is H2O, it will also stay blue. That's how blue litmus papers work. Now, in the case of the red litmus paper, when you put the red litmus paper in an acid, it retains its color, it stays red. But when you put it in a base, it turns from red all the way to blue. And when you put it in a neutral substance, it stays red. So in summary, what I can say is blue litmus paper is used to identify acids because that is where its color change comes alive. And then the red litmus paper is used to identify bases because that is where its own color change comes alive as well. Now, here is an example on the screen of how a litmus paper is used. When a litmus paper is placed in an acid, the blue litmus paper, you can see the color change moving from blue over here to red down here in the solution that it was placed in. And the same thing applies to the red litmus paper. You can see the color change moving from red all the way to blue over here when it was placed in a base. So basically, that's how the litmus paper is used. And here is a very good example with one of the relatable substances that you have in your house. If you take the red or the blue litmus paper and you place it in lemon juice, I have a picture of some lemon fruits over here on my screen, and of course you know that lemon is acidic in nature. That is why the acid that is contained in lemon is called citric acid. So you can see a blue litmus paper over here being placed in a lemon fruit. It makes the blue litmus paper to change from blue all the way to red. That is telling us that lemon is acidic in nature. It's an acid. So that's one case where litmus paper was used to test one of the relatable substances that we have in the home, which brings us to the next indicators that we want to talk about in this video. We're talking about phenolphthalein and methyl orange. Okay, so these are liquid indicators. In the first case where we talked about litmus paper is actually a solid indicator because paper basically comes in the solid state of matter. So in this case, phenolphthalein and methyl orange, these are actually liquid indicators that are used more often in laboratories or in titrations. Titrations are chemical reactions whereby an acid is reacted with a base in order to find the concentration of the two of them. Now, proceeding further, let's start with phenolphthalein. Now, phenolphthalein is an indicator that can be used to identify an acid and can be used to identify a base as well. If you place phenolphthalein, now here is what phenolphthalein looks like. You can see the bottle of phenolphthalein over here, and it is in its liquid state. So if you place phenolphthalein in an acid, you can see an acid over here and phenolphthalein has been placed inside. You can see that there is zero color change. There is no color change when phenolphthalein was placed in an acid. So if you place phenolphthalein in a substance and you see that there is no color change, it is simply telling you that that substance is an acid. But over here you can see phenolphthalein was placed in a base and there was a color change from colorless all the way to the pink color. So when you see a color change when you use phenolphthalein and it changes from whatever color it used to be and it changes to a pink color, it is telling you that that substance is a base. Now here is a good example, an illustration that we have over here. You can see this video that is playing out at this point. You can see the substance is first colorless, an acid. When you added phenolphthalein, there was no color change. But when you added a base, sodium hydroxide to be precise, you can see it changed from colorless all the way to pink. So that's how phenolphthalein is used as an indicator to identify acids and bases. That brings us to methyl orange, which is the second liquid indicator that we want to talk about. Now, methyl orange is also existent in the liquid state of matter. When you place methyl orange in an acid, it turns red, like we can see over here. The color change that was shown is the color red, and when you place methyl orange in a base, it turns yellow. It turns yellow. Remember, for phenolphthalein, let me name it pH. When it is placed in an acid, there is zero color change, and when it is placed in a base, it gives the color pink. But for methyl orange, MO, when it is placed in an acid, it gives the color red, and when it is placed in a base, it gives the color yellow. I trust this video is being educative for you. If it is, please do me a favor by liking it, subscribing to my YouTube channel, and turning on the notification bell icon so when more videos like this come out, you'd be the first to be notified. Now, let's talk about some simple tests that you can do on your own in the house or in the laboratory, because let's face it, if chemistry cannot be brought to be practicalized in your home and applied to your everyday life, then what's the essence? So the first test we want to talk about is the lemon juice test. If you take lemon juice, for instance, I have the picture of some lemon over here on the screen, and you take blue litmus paper, you can see over here the color that is identified is the color blue, and you place it on the lemon fruit. You can see a color change moving all the way from blue to the red color. So what do you use when you want to carry out the lemon juice test on blue litmus paper? You use kitchen lemon and you use a blue piece of litmus paper. What will you see when you apply it? You will see a color change moving all the way from blue to red. And what does that tell you? It tells you that the substance that caused that color change is an acid. That is test number one. Test number two, if you use soap water, some water that has been mixed with soap and it has become a little bit foamy, if you use it on red litmus paper, like we can see over here, we have a piece of red litmus paper and we have some soapy water that's been mixed with some soap and it has changed its color. You can see the color changing all the way from red over here to blue over here. So what does that tell you? When there is a color change from red all the way to blue using litmus paper, it tells you that that substance is a base. That is another test that you can carry out in your home using litmus paper. And then the third test that you can actually carry in your home is the test using vinegar and baking soda. Now, in most kitchens, we have vinegar and we have baking soda. When you take the two of them and you mix them in a cup, like I have the illustration happening over here, here is some baking soda and here is some vinegar. When you take the two and you place them in a cup just like this, you can see there is a chemical reaction that is happening and some bubbles are beginning to form. Those bubbles that are forming are the product of an acid and a base reaction that is releasing carbon dioxide, CO2. Now, carbon dioxide is also the same gas that comes out of your carbonated drinks. Carbonated drinks like Coca-Cola, carbonated drinks like Sprite, carbonated drinks like Pepsi. Generally, all soda drinks contain CO2. That is why when you open the bottle, it makes this sound. So that's what's going on over here. When you mix baking soda and vinegar, they react together to produce carbon dioxide gas. And just for your information, this over here, baking soda, is the base and vinegar is the acid. I trust you're enjoying every bit of this lesson up until this point. So now another test that you can carry out to identify a substance as an acid or a base is the cabbage juice test. Now, how do you do that? You can do that by boiling some red cabbage. Okay, you boil some red cabbage. I have the picture of what a red cabbage looks like over here. You slice some of them, place them in water, and then you boil them. When you boil them, the water will change its color from colorless to somewhat a purple color. Now, that liquid that you now have available can be used as an indicator to test if a substance is an acid or if a substance is a base. Now, here are some examples. Baking soda, for instance, which is a base, gives off a green to a greenish bluish color, and you can see water over here, which is neutral. And neutral substances don't show any color change, and you can see the color over here, which is purple, is the same as the color of the cabbage, so there was no color change. So in this case, water is neutral. And you can see vinegar, which is an acid, it gives off a red or a reddish pinkish color. So that's how you can use red cabbage in your home as an indicator to identify whether a substance is an acid or a substance is a base. Now, that being said, here is a brief exercise I want you to carry out for me, and then you drop the answers in the comment section below. If you add phenolphthalein to a solution and it turns bright pink, what does that tell you? So I'd like you to go over this question and drop the answers that you think are correct for me in the comment section. I'll do my best to respond to each and every one of them. So that's it for today's video. I want to thank you for hanging out with me and sticking around till this point. If this video educated you in any profitable way, please like it, subscribe to my YouTube channel, and turn on the notification bell icon. Up until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so Chemi can make history. I will see you in the next video.